All right. Hi, everyone. I'm Abhi from Team 7461, and we're going to be talking about success as a less established team. So meaning anyone who's not either a less experienced team like first, second year, or a team that just doesn't have that much mentorship. And we're going to be talking about how to find success despite that. So, who are we? I'm Abhi. I'm a senior at Tesla STEM High School in Redmond, Washington. I'm the captain and founder of Team 7461, and I like science fiction.
Hey guys, I'm Max. I'm a junior at Redmond High School, and I'm the design lead of Team 7461. And I love reading.
All right, so about our team. So as we mentioned, we're from Redmond, Washington. We're a relatively small team with around 25 students, and we've been largely student driven throughout our existence. We actually didn't have any mentors our rookie year, and we currently have one mentor. So we're kind of used to operating without that heavy mentor experience. Um, and so who this is for, I mentioned this earlier, but this is for teams without much mentorship experience, or just anybody who's really low resource in that regard, where even if you've got access to machining, for example, or a lot of funds, you're not sure how exactly to use it, or you're not sure, like you don't have those mentors with first experience who you can rely on. So again, using us as an example, we've got one non-technical mentor for over 30 students. And so some general advice. One, if you don't have mentors, find some by all means. Like as much as this presentation is about operating in the absence of mentors, like even if you can find some non-technical mentors to manage your orders or just help out with running your program, it's going to do wonders for your ability to succeed. Because if you have, even if say you're a really good designer, you're not going to be able to design that high quality robot if you're spending all of your time worrying about who's getting to meetings, arranging carpools, figuring out the logistics of how parts are getting ordered and all of that stuff that realistically you shouldn't be focusing on. And second advice is take it from somebody who's been there 1,000 times. If it comes down to robots and health, always pick your personal health. Like especially like usually with teams, there are a lot of programs which will have like mentors students can rely upon. But if you don't have those mentors and you're stuck doing stuff like um, running the first Inspire system because your mentor isn't involved and just gave you the password, or dealing with parent drama, both of which have happened on our team, just prioritize your personal health. Trust me, it is not worth it to sacrifice it just for robotics. So that's just general advice to anyone out there in that situation. So that being said, let's get into how to technically succeed. So if you're focusing on the robot, here's how you'd actually, I guess, work towards building a competitive robot in the absence of either multiple years of your own experience or mentors with experience. So the biggest thing is external review. So I guess if you're a team who say, for example, us, we don't have any technical mentors and we were a second year team this year. And so obviously we did not have the experience on our own to actually build a good robot. So what we did in order to, I guess, field something that was somewhat competitive was actually get all of our stuff reviewed by someone outside of the team. Because honestly, if you're able to get that design review elsewhere, you're going to be able to, I guess, sort of simulate having that experience on your own team. So, I guess with this, one, secrecy in FRC, in my opinion, unless you're like 254 or somebody, you're not going to get a benefit out of being secretive with your robots. So, like, for example, in 2019, our team had a no disclosure policy because we did not want to be sharing our stuff out there because we sort of fell into this whole people might copy us idea. Like, that's just nonsense. Unless you are one of those top tier teams, nobody's going to actually end up copying you or get an advantage from doing it. And you're just losing out on all of that potential design review. And as I said, this compensates for your lack of experience. So, like, me personally, I've only, like, it was our second year as a team, but because we got review from people outside of the team who had like decades of first experience, we built a much more competitive robot. And this can be formal or informal review. So it can be something simple as sending a screenshot to somebody and being like, what do you think? Or something as formal as just sitting down for an hour and going through the full robot CAD with like all of the different, explaining all of your design constraints and just doing a formal design review. And again, this happens at any stage in the design process. So if you look at the photo on the bottom left corner of the screen, you'll see that's like week 1 CAD. And this was us evaluating concept similar to 2910 Jack in the Bot this year, with a ball tube that feeds into a shooter. We later dished this for a V-hopper, but this was a screenshot I sent to someone week 1 just asking, would this concept be viable? And they gave us a lot of advice. For example, that one intake was really bad and we completely redesigned it. And so that's sort of, I guess, what you should be looking at when you're doing design review. Like, it doesn't need to be something super formal. It can just be, here, take a look at this. How does this look? And somebody can give you feedback. Like, for example, with this, we weren't powering both sides of our hopper, which what would have caused jams. And also we had a bunch of different issues with that. And also other places you can get review, or one, you should always reach out to more experienced teams. So for example, we reached out to a couple local powerhouses as well as some just people we met through the community. And some great resources include the FRC Discord and Chief Delphi. Because, for example, if you look, that's a post I made asking for some review on a gearbox I was designing. And similarly, the Discord's a great place for informal review and just like sending some screenshots and getting ideas. And so if you're getting, I guess, after getting external review, the second most important thing you can do is be strategic about your design. So, I mean, I guess they're of similar importance, not really second most important, but one, always build within your team's limits. So if you're a team with like 10 kids and you don't have much manufacturing, don't try building a super complex turreted shooter with that can shoot from the trench, for example. Like, that's not something that you can feasibly achieve. So it's always best, like, if you, as someone put it, if you have 30 units of robot function, it's much better to have 3 functions at 10 units each than 5 functions at 6 units each. And so part of this is also not wasting energy on non-essential tasks. So for example, if your team doesn't have the resources to do a custom drive base, then spending that time is not going to be you're not going to get a benefit from doing a custom drive base over a kit of parts chassis if that takes away from your manipulator function. So that's one of those things that's not absolutely essential. And similarly, you should always avoid complexity wherever possible, because say you've got 2 options, like you can either shoot from somewhere rammed up against a wall, or you can try designing a really crappy adjustable shooter. You're always going to get a better result with something that's simple and reliable, at least until you've already built adjustable hood shooters and you know you can do them. And part of this is also stealing from the best and inventing the rest. So like, for example, in 2011, you had to pick up this round tube object, and it was essentially the same object as in 2007. And so, for example, what Team 1678 did was they actually took a manipulator from 2007 that was really successful, copied it, and then just built basically the exact same thing. And that was their first year going to the championship, I believe. So that just goes to show that you don't always have to reinvent the wheel. You can focus on improving what already exists out there, which will get you much better results. And also, making trade-offs is incredibly important. So for example, if it's a choice between shooting into the high goal but bad, or scoring into the low goal well, you can trade off the ability to score in the high goal for much better low goal performance, and that'll net you a better robot. And also, one of the biggest things is that time is your most valuable resource. So you want to be done with your robot by the end of week 4 of build season, because after that point, you want to be able to iterate, test autos, and do driver practice. Because at the end of the day, a good driver with an okay robot is going to be much better than a really, really good robot with a bad driver. So spending time doing like small changes in CAD, taking the time to get every little detail right versus just building something and then iterating on it, the latter is always going to be more successful. And I guess an example of strategic design would be Team 5160 this year. They won an event as a first seed. They just had a straight up every bot. They had a control panel spinner as well, but their robot just took the Robonauts every bot design, built it, and suddenly, and they've got a really good robot that was reliable. And week 1, they won their event as a first seed, even though there were teams at their event that had these super complicated turreted shooters and whatnot, because they focused on getting something done and then had really good driving to back it up. And another thing that I'd say for low resource teams, say you've only got like 2 kids who are able to design, it's always good to conserve energy where you can. So you don't need to prototype every concept. You just need to prototype some stuff and learn from other people's prototypes. So for example, our team did not prototype a shooter this year because we didn't have enough bandwidth. And we knew that Gray T Products was making a shooter. And since we knew that the people who are making Gray T stuff probably know how to make shooters better than we do, given their mentors with a lot of experience, we, instead of spending our energy there, we spend our energy prototyping intakes and hoppers. And then just when the Gray T shooter came out, as you can see on the right hand side of the screen, we pretty much just took the geometry, and in an hour I just sketched out a plate that would integrate with our existing design and use their exact hole pattern. And that ended up being the shooter we ran at competition. So it's stuff like that that can really save you energy and allow you to focus on what matters. So also, you can learn from the Everybot Robot in 3 days, the West Coast Product Competitive Concept, and the Open Alliance, which is a group of teams that have open build blogs. And for example, 6328, which is the blue robot on the screen, they had pretty much all of their stuff public, and they built a phenomenal robot. So you can, and they prototyped a bunch of different concepts. So you can use those prototypes and see without actually building them yourself. So for example, that V-hopper concept, we didn't actually do much prototyping of it. We pretty much just looked at someone's prototype and realized it worked better than the prototype we had of a linear ball tube and just went with it. And also use off-the-shelf parts where you can, because for example, the kit of parts chassis, like, it gets a lot of hate, but at the end of the day, you're saving that time designing and building a drive base so you can focus your energy on the parts of your robot that are going to influence scoring more. And similarly, like in elevator games, you can use things like the Gray T elevator, which it's a really solid elevator. You don't need to do the work of designing it, which allows you to focus on iterating and refining your scoring mechanisms more. So yeah, in general, just conserve your energy where you can, because at the end of the day, nobody is judging you for how much of your robot you did yourself or how much your robot you took from you prototyped it yourself, you built it yourself, and you did everything in that process. Because if you're able to take somebody else's work and just integrate it into your robot and then focus on iterating the other parts, you're going to end up with a much more competitive robot. And finally, the last thing I have to say is that practice makes perfect. So for example, well, I guess in the off season, you should be doing a bulk of your work, because if you don't have that experience to rely upon, like you don't have a mentor with decades of first experience, you don't have any of that, you're going to have to substitute that experience by building up your own experience. So, for example, off-season competitions are a great way to do this. We rebuilt our robot twice in the 2019 off-season, which allowed us to build our team up from a consistently unpicked team to our last competition, we were the first pick of the fourth seed. So it's that sort of iteration and improvement that can really sort of um, compensate for less experience by giving you more experience just building robots. And other places for practice are catathons, as well as building miscellaneous projects like elevators, arms, shooters, autopaths, rewiring your electronics panel. And it's important to keep in mind that this won't lead to instant results because, like, Rome wasn't built in a day. But over time, by practicing and iterating more, you're going to be able to actually substitute that lack of experience with some of your own experience. And that screenshot at the bottom of the screen, um, it's just those are all of the robots our teams worked on to date, including some catathon submissions, some robots that we've actually built, and just and this is not including all the miscellaneous projects we've done, including smaller mechanisms and whatnot. So this is just I guess full robots we've designed, and that's just showing how, like, for example, the first 6 of those were all done before our 2020 season. So that's what it takes to sort of build up to a competitive robot, is just practice, practice, and more practice. Because with each design, you're learning something new, you're learning how to package something better, and you're overall just sort of refining that knowledge base that you have, such that even if you don't have that, again, I talk about this a lot, but this is a this is probably the best way to, I guess, replace that knowledge base that a lot of teams have of their mentors having decades of first experience, just by building more robots yourself, so you have that experience despite being in the program for less time. And obviously, this isn't like a perfect solution. You're obviously not going to become like Adam Hurd in a day. You've got It takes time, and you're obviously still going to be less experienced. But by doing this, you build your experience to the point where you're no longer just you're. I guess it's more of just iterating as much as you can on your skills, such that when it comes time to build a robot, you've already seen a bunch of different possibilities. You've already seen how different styles of mechanisms work, and you're better able to apply that to a robot.
All right. Yeah. So, along with technical aspects, non-technical aspects are also very important for your team succeeding. This involves a lot of administrative stuff, a lot of managing the resources that you do have in order to maximize your potential on the field and throughout the entire season. Right. So the first thing that's really important is planning ahead. Especially when you're a team with low resources, planning ahead can definitely be a strong start to how you to your season. You want to plan your season in detail. That means every minute of every meeting, because meeting time is valuable, and you want to as a low resource team, you can't afford as much inefficiencies as maybe some other teams with a greater inventory of resources that they can fall back on if something goes wrong. Yeah, so you want to use the plans that you make as sort of like hard deadlines, even though like the FRC season doesn't have that many hard deadlines, like besides comps, like your first comps or when build season starts. You want to create hard deadlines for yourself in order to keep yourself on track, because otherwise, if you don't, then the season flies by before you know it, and you're stuck going to first comp with a suboptimal robot, like what we experienced in a rookie year. Yeah, so the way you want to approach kind of the planning process is you want to plan out all these key points and key times in your season, as well as like each meeting and how you're going to structure each meeting. But then after you reach a certain point in your season, you want to look back on those plans that you made, kind of reassess like what went wrong, or like what you've got done, what you still need to get done, and how that's going to affect like the future points in your timeline. And then you want to readjust for that. Maybe scrap some ideas. Maybe say, hey, we need to set aside this meeting purely for prototyping just to get this one mechanism down. Just make your schedule more flexible and adapt to whatever conflicts come in your way. And what planning ahead does is it helps keep you from overscoping. And what I mean by that is from over assessing what you can do. A lot of rookie teams come into the season thinking, this is full possibilities. We can do anything. But in reality, as a low resource team, there are definitely limits that you have to keep in mind. And planning helps you stay underneath those limits. And even if you do exceed those limits, next time you can better understand what exactly you need to cut back on, what you can maybe expand in, and other factors like that. Just on the right here, we have I think this is like our kickoff meeting schedule for the 2020 season. If you see, we basically laid out the entire day, Saturday and Sunday, and then we also kind of brainstormed the general overall meeting structure, moving on from there. Next slide, please, Abby. Oh, thank you. All right. Yeah. Next thing is documentation. This is pretty similar to planning ahead, except this is focusing more on actually documenting what you're doing throughout the season. So the first thing is obviously to keep an active to-do list, and what that refers to is a to-do list that you're continually adding on to, and you're like continually looking back on. So, for example, during our season, we after our initial strategic design meeting, we kind of set down some basic to-dos, and then we as the season went on and we accomplished some of those to-dos, we would keep laying down more to-dos and expand and basically keep branching out. So that really helped us stay on task. It helped us kind of show us where we came from and how we've progressed. And then it's also really easy that way to look back and maybe take a rewind. Step back a little bit. Let's redo this, and just help you have a more productive season and more organized season as well. So you want to document both your failures and your successes. This is really important because you want to know what you can improve on and also what works, so you can do it again next time. And these documented experiences are really important when you're looking back on it, either later in the season or even during the off season, when you want to say when you want to take a look back on the errors you've possibly made and readjust some plans for the future based on that. Yeah. So, and also you want to build up on these documents. So when you see these big planning documents and all these red highlights, green highlights, stuff where you've done right, stuff where you've done wrong, you can easily turn those into resources for future seasons. You can very without much effort make these a really powerful learning opportunity that future generations of your team can take away from from your mistakes, and that basically ensures that your team is staying on an upward trajectory throughout for the future seasons. Right. Student leadership. This one's really important because in the absence of mentors, the student leaders really have to step up and take the stage. And in a strong team, you always have like a strong set of student leaders. even if there are strong mentors, there also has to be strong leaders, because strong student leaders, sorry, because student leaders are what are most effectively set the paradigm in our experience. Even though like mentors, obviously they're adults, they're really highly organized, really professional people, but students, they look up to other students. So if your student leaders emphasize values such as proactivity or taking ownership, then everyone else will follow suit. You'll have people actually looking for tasks to do instead of waiting to be told them. You'll have people like stepping up to take ownership of a certain project, or to design a part, to manufacture a mechanism, to lead. It helps take some of the load off your shoulders, and it also makes the season run a lot smoother. And this kind of leads into the concept of leading by example. In order to set this paradigm, you have to um, be it. You have to take the team into basically your own hands, kind of um, set the example for everyone, show them what they can do, and then enable them to take that step and be a leader themselves. Right. The next thing that's kind of important is delegating roles. This kind of ties back into Abby's earlier point about mental health, because in a low resource team without many mentors, like the student leaders really take the brunt of the management responsibility. They have to do all the logistics, and also manage their sub teams and the tasks within, like, administrative tasks within the team. So it's really taxing on the person. And when you're delegating roles to maybe other positions in your leadership hierarchy, or to members, to your just non-leadership members, then that really provides a really healthy work environment where everyone's engaged, everyone's active, everyone's taking responsibility, everyone's being proactive. So that's just a really great step to take. Is just delegating and delegating efficiently as well. Yeah, so that's just our leadership structure. We have a captain, vice captain, then we have a sub team leads, and then the mentor kind of looks over everyone, makes sure everything's running smoothly, has some like mentorship roles for the students, and also deals with some maybe some sponsor or parent relationships.
Yeah, so I just want to go back to that leading by example thing for a second. So if you look at, if you say the biggest example of why leaders need to set an example for students is because if you're, say, I guess a good example would be like, say your team, say you've got a club president who does not show up to meetings, will, or even if they do come to meetings, they kind of just do their own thing, ignoring other members. That's sort of the example younger students are going to look at and be like, either they'll see that and go, okay, so I'm not being involved. I don't want to be a part of this team, or I'm not expected to do work. Or also, if the person, say, just does not put in any effort, that's sort of the expectation that gets passed down to newer members. So what you want to do is make sure that you're always being, like, a student leader should always be the one coming in early and leaving late, whether that means staying late to clean up, taking inventories. I guess the people in leadership have to be sort of super members, in a sense that they have to be all of the duties of a regular member plus additional responsibilities, and taking additional ownership for, say, like in our case, we've got students who, if like a situation got hairy with the student's parents, we'd have leadership leads like take the initiative to resolve that situation before it got to a point where it was unmaintainable. And so I guess leaders have to set, and if they set that example, we found that younger students are going to be willing to put in that work to, I guess, emulate that in the capacity that they can. And so, especially in the absence of adults to set the tone for a team, it's really those people who are like the team captains and club presidents who are setting the tone for their program.
Right. Yeah, and it's especially important when you get like when you have the sub team leads really kind of involving those members that aren't usually like the first ones to answer the question, the first ones to raise their hand. It sets that gracious professionalism environment where everyone is helping each other, everyone is trying to build a better team just together. It's so okay, and then moving on. One thing that we found really helpful is that having a super defined member handbook allows for like efficiency in a number of areas. So when you have a defined member handbook, which basically just says what the responsibilities of a member is, how member relationships work, how like the team is structured, and what roles do like parents, mentors, sponsors, all those, like how everything basically revolves around each other. That allows for people to become more productive because they are held accountable, right? There's a standard set like that's written down of what a member should be doing, and so that basically allows everyone to keep each other accountable and hold themselves accountable. And so the next thing is that prickly situations do in fact happen. Conflicts always arise. It's hard to avoid. There will be different ideas, different solutions, different issues, and it's really easy to lose focus and get sidetracked on like when those arise. So having a member handbook that really defines how you deal with those conflicts and what some effective resolution pathways that you can take are, it really helps get over the conflict faster, make your season more productive, and you have less bumps along the road, essentially. Yeah, and also it really helps when you're trying to maintain good relationships with parents, sponsors, and mentors, because and other teams and partners maybe, because these guys are really valuable resources, right? Parents, they drop you off in meetings, they support you with their time. Mentors, they're also giving their time and putting in so much energy to help the team grow. And these, depending on whether or not you I guess utilize these resources well, they can really make or break your team. They can make a season really great, or they can really make it a burden, or a like make things not go super smoothly, which slows everything down. It's not really great. So having a defined member handbook, it's really helpful when you're dealing with this, because you have a written standard of how you deal with these relationships, how you maintain the relationships.
Right. So one thing I do have to add to that is that your parents are probably, especially if you don't have that many mentors, the parents are going to be one of your biggest resources. And I guess I cannot stress this enough, don't piss off your team's parents. If a parent wants to lecture you for half an hour at district championships about why you have to build a wooden scissor lift cart, totally hypothetical situation, never happened before. But if that happens and you don't have anywhere else to be urgently, you sit there and you listen to it. Don't be disrespectful, because normally there are mentors to handle that type of thing, especially if there are super aggressive parents, say yelling at students or getting pissed about the way the team is run. But in this case, students have to directly interact with parents, which, while it's a very tricky situation, you have to manage it. You can't be disrespectful at all. If a parent, say, is chaperoning at a competition, don't ignore them. Listen to everything they say. I cannot stress this enough. If your parents are pissed off, it can cause absolute nightmares for the students, just because some aggressive parents have a lot of time on their hands, and they can essentially cause many problems for team. And also, part of that, one thing we found that works well is having a couple parents who are reasonable, who you can sort of direct those other parents to. So in our case, we just had 3 parents who we sort of decided were, I guess, very, very um, understanding, and they were able to sort of mediate that. And finding those parents is going to be one of the best ways you can sort of start to mitigate the burden of that situation.
Right. Yeah. And then also just I think Abby also touched on this, but when you're a low resource team, parents sometimes take some roles that would normally go to mentors, right? Like logistics, giving students rides, chaperoning at events, and all that like causes a lot of opportunity for conflict. And it's just a really great tool to have for like a conflict resolution plan, or just whatever form that may take, whether that be other parents to help mitigate that, or have a student representative maybe to specifically voice student opinions to parents. It's always there's so many solutions you could take, but it's always great to just have one like that you write down and have it standardized.
Also, I just want to say, I guess, so maintaining good relationships with parents is extremely important, but also one of the big things that can happen as a student is you get into a really tricky situation and it starts consuming, like you have no idea how to deal with it, because obviously adults are scary. And if, say, some kid's parent is yelling at you about, say, why you should kick another student off the team, which has happened before, for us at least. So you need someone who you can go to for advice. So this can be a teacher, and trust, who has a lot of experience, or a mentor on another team you're good friends with. And by having the ability to ask them questions about those tricky situations, you can they can help you deal with that type of thing. Since obviously a sophomore in high school does not know how to respond to a parent yelling at them to kick another student off the team. But if you can talk to a teacher or a mentor on another team about how their team might have dealt with similar situations, you can bring that situation to a much better resolution than if you were dealing with that on your own. So, and then the last part of our presentation is going to be talking about specifically how this applies to rookie teams, because obviously being a rookie team is very different from being an established team. You've got less stuff on you don't have a lot of things. You don't have materials that you can prototype with often. You're you pretty much have no experience with robotics. And so we've got a couple of things we put down specifically for rookies. So the biggest way of succeeding as a rookie team is through Rookie AllStar. And this award, a lot of teams are unaware of it, but it's a good way to advance. And it's also just representative of what will make you successful as a team. So even if you don't win Rookie All-Star, you should still do all of this, because it'll make your program much more sustainable and give you a good foundation going forward. So a couple of the biggest things for that judges look for in Rookie All-Star is impactful outreach. So things like demos, mentorship of FLL, VexIQ teams, presentations at sponsors, building those community connections. And again, this is probably the biggest thing they look for, because a team that has that as a rookie team automatically stands out from the rookie teams who say they got a grant to start a robotics team from the state, and they met twice a week during build season and showed up to competition with just a kit of parts chassis. And so this outreach is sort of even if you've got a comparable robot to another team, the biggest thing that'll set you apart is just having that outreach and sort of knowing what FIRST's about. Because at the end of the day, FIRST is about getting the message out there about STEM, and having outreach is sort of essential for that. And also, it's really useful to plan for sustainability, not just because judges are looking for a team that will succeed long term. They're looking for a team that can win the Chairman's Award in 4 or 5 years. So this includes having a business plan with your sources of income and all of your sponsor relationships detailed, and also determining future sources of members funding, and just planning for, and also identifying potential threats to your program, such that going forward, your team will continue to be a thing. Because again, first, as much as First does push growth above all else, they do care on a good level about how sustainable teams are. And it's sort of your responsibility as a team to make sure that your team just doesn't die after 1 year because you couldn't find funding. And finally, even if you have all this, the key to actually wrapping it up is having a solid presentation. So part of this is having really consistent branding across all of your documents. So on the right, you can see our display from district championships where we competed for the Rookie All-Star Award. And we sort of had a consistent theme throughout. We had all of our documents were very consistent, and we had brand standards that sort of defined how each document would look. But also practicing beforehand when talking to judges is important. So for example, what we did was I literally went on the FRC Discord server and I asked if anyone could ask us questions that judges might ask, and just answered like somewhere near 50 or 60 questions the day before we had to present. And that sort of practice means that you'll already have answers, even if they don't ask the exact same questions, you'll already have sort of a pre-formulated semi-answer to their questions. So you aren't stuck, like, you're able to succinctly state what you've done, what you've accomplished, and essentially why the judges should give you the award, which has a huge, if you're prepared for this, it can have a huge impact on the way the judges see your team. And also, if anyone's asking, we did rebrand from 2019, so that's why our team name was Binary Circles then. Nobody really liked the name, so we switched. And so technical success as a rookie team. So everything I said earlier applies twice to a rookie team because you don't have, like, as I said, you're especially low resource as a rookie team because you don't have all of the parts to prototype with. You don't have the bandwidth often to prototype a bunch of different concepts. And so what you should do is, first of all, ways to one, keep everything I said in mind, especially the parts about external review and not reinventing the wheel and stealing from other teams. Those apply doubly here. But also, in addition to that, preseason training is incredibly important. And you can find local teams. For example, Apex Robotics 5803, I reached out to them the summer before rookie year, and they came in one day and just taught us how to do electronics. And stuff like that is how you sort of build that foundation. Sometimes teams will often have like a kit of parts chassis or something they can just donate to you and let you learn with before your season. So definitely reach out to as many local teams as you can. And in addition, again, don't reinvent the wheel. I cannot state this enough. This is the biggest key to success as a low resource team, is avoiding having to re-engineer things. So letting others do the work for you, essentially. So for example, the kit of parts chassis, like, sure, it's functionally the same as any custom drive base that's a tank drive, but especially as a rookie team, you don't have the time to redesign your chassis to be, I guess, a couple grams lighter or whatever. And also, you don't have the time to be debugging issues because, like, if your drive base is constantly throwing a chain, you're going to have bigger issues to worry about. Like, because, as I say later, something will always go wrong. So, especially with your superstructure mechanism. So you want as reliable of a base to build upon, and also you want to get done fast. And the other thing is the Everybot is a great resource for teams. Robonauts, for those who are unfamiliar, Robonauts 118 put together a simple design that they call it the Everybot. Any team can make it. It's under $1,000. And 9 times out of 10, a rookie team cannot design something that's better than it. But by taking that design and improving on it. So for example, in the picture on the right, Team 7419, they actually took that design and improved on it to the point where they added a level 3 climber. And this is 2019, by the way. They added a HAB 3 climber, and they sort of improved the rigidity of the design and just made a bunch of functional improvements that helped them rank second, I believe, at one of their off-season competitions. And they ranked top 8 at both of their in-season competitions. So if you have I guess it's a question of is it better to design something from the ground up or take something that works and just refine it as much as you can? And again, if you're a rookie team, the answer is almost always going to be taking something and refining it. And a couple of other just miscellaneous tips for doing well with your robot: moving every match. If you move every match, you will most likely get picked, because especially at week 1 events, most teams are not, like, especially in a third robot, they're just looking for someone who can drive around and play defense. So by moving every match, you give yourself a huge advantage. And that means just having a really robust electrical system and testing a lot to make sure you don't have like any fundamental issues. And also, something that a lot of people don't talk about is keeping your team together at competitions. So speaking from personal experience, our team got DNP'd by a couple of teams who were looking at picking us at our second event in 2019, because they came over to our pit to ask us a few questions and noticed that everyone was arguing and there was chaos everywhere. So that sort of thing can really have a huge impact on your performance. So it's best, like, I guess, just make sure your pit isn't like a chaotic mess. Everyone's not yelling at each other and that sort of thing, which is pretty hard as a rookie team because, like, again, there's a lot of people are new. There's a lot of tension that can happen within a robotics team, but especially a team that hasn't really worked together that much before. But just by doing that, you give yourself an advantage when people are looking to pick you. And I think that's it for our presentation. So if anyone has any questions. All right, so somebody asked, how do you vote in your leadership? So that's actually something we don't do. So our team's actually found that elections are not a very good way of choosing members of student leadership, because I guess the biggest thing is that elections are generally going to end up being a popularity contest. So if you don't have mentors to do it, then elections might be the only way. But generally speaking, what we tried to do is, this year we did have one, as I mentioned, we have our coach, even though he's non-technical, he's super invaluable to our team. And so what we had was our mentor essentially picked captain and vice captain based on the applications. And then from there, mentor, captain, and vice captain did interviews for the rest of the positions of leadership. So that's how we do it now. If you don't have mentors, what I'd recommend is either consensus based, or elections are sort of a last resort thing if you don't have any other way of picking, because elections can just turn into a popularity contest, which doesn't end up benefiting your team. So is our member handbook accessible to the public? No, it is not. Unfortunately, we actually we're not done with a lot of the formatting, and it's sort of a living document. So we haven't really thought to release it, but we will be. And somebody asked, I think we might make it public sometime soon, once we've got, I guess, a version we feel comfortable releasing. And how old is our team? We are a third year team now. We were a 2019 rookie. Do we have a website where somebody can find our documentation? Yes, we do. So that's actually the next slide. Either email us at team746one.com or sushisquad.org. Our 2019 documentation is on a Chief Delphi thread. So Team 7461 2019 documentation, just search it up and you'll find all of our rookie year documentation. And I don't believe our 2020 documentation is up yet, mostly because we've still been working on it. It kind of took a back burner once COVID hit, but we will be publishing that sometime soon. So. What's the best piece of advice that I would give to rookie teams? Max, you go first.
Okay. I would say maybe it is don't expect too much. Like, you take this season, take your rookie season as purely a learning opportunity. Try to learn as much as possible, and basically, yeah, just grab as much from it. Don't be super bummed out that you didn't, get win your event, or you didn't make wake worlds or anything. Just try to learn as much from it so you can maybe have a better chance next year. I think that's just like, yeah, don't take it super seriously and have a bunch of breakdowns and that kind of stuff.
All right, so I'd say for me, the biggest piece of advice I'd give to rookie teams is, as much as I guess personally, I'd say from a non-technical standpoint, what Max said, yeah, don't, your rookie year is your time to fail. Just keep iterating. But from a technical standpoint, I'd say 9 times out of 10, you're wasting your time if you're designing a mechanism entirely by yourself. Like, for example, our 2019 robot, we built a really crappy arm, and we ended up, oh God, we did not do very well at our events. Our arm caused much strife. It broke more often than not, and it was just in general a waste when we could have built in every bot perfectly fine and focused on iterating a climber or just like building that mechanism better, which would have been, I guess, much more enjoyable to compete with since we wouldn't have constantly had to watch it fail, but also just much more educational because we would have been able to actually, it, um, what's it called? We would have been able to, I'm blanking, but we would have been able to actually iterate a climber, for example. And also, on top of that, I guess part of the thing I'd say for rookie teams is just iteration is, I guess, one, have your get a lot of external review, like have people look over your CAD, have people, I guess, make sure you're on the right track and get that external review really early on. So for example, that way, like somebody can tell you, hey, this, you should probably be doing in every bot, you're not going to get any functionality, that sort of thing. Or say, have you looked at this prototype by this team? And also, yeah, I guess they're pretty much, also the biggest thing I'd say is if you're designing a mechanism, one, be ready to iterate on it, be ready to not get it right your first try. But also, if you're designing it, be sure to do all of the background research you can. Watch like, if there's 5 videos out there, you watch every single video on that type of mechanism. Like if you're designing an arm, you like absorb every resource possible and look at examples, because if you try doing it yourself, you're going to end up with something that has a bunch of flaws that you could have mitigated by looking at other people learning. If I could change one thing about our rookie year, what would it be? There's a lot of stuff I would change. Yeah, probably what I said earlier about doing in every bot and improving on it. Just because from a robot standpoint, that would have been better. Also, putting more emphasis on a working electrical system and just taking more time into making that much more reliable and robust, because that would have done wonders for our performance. Also, actually iterating on our cargo mechanism, because what we did, we had a mechanism that worked, but we had a bunch of flaws, and we sort of wasted our time on a bunch of different like smaller improvements that really at the end of the day did nothing, when we could have focused on actually improving that and perhaps doing better. What was your inspiration in your rookie year? So I'm not sure what that question means, to be honest, but if it means like teams who inspired us, I'd say some of the teams that inspire me most personally are teams like 148, 1678, and just, I guess, those powerhouse teams who, like, you see those robots and you go, I want to build those robots. And sort of that was like my inspiration for just keeping on improving, was the like thought that maybe we'd be able to build a cool robot like that someday. What is our student to mentor ratio? We have a 30 to 1 student. Actually, no, with our new members, something close to 45 to 1 student to mentor ratio. So, yeah, there's a Chief Delphi post. Our team's looking for mentors. If you're in the Seattle area, please mentor us. 5. All right. Yeah. Do we do chairmans? Unfortunately, no, we did not get to submit for the Chairman's Award this year. Mostly because this season we were all really focused on our one goal was doing as well as we could competitively. And so awards sort of took a back seat. And also we didn't have the manpower to really focus on chairmen because we didn't have any people who could work on a submission who weren't essential to our robot. So for example, our imagery lead was also our programming lead this year. So yeah, we didn't have the ability to do a chairman submission, and most of our documentation wasn't done by our first competition. But we are planning on submitting next year, if there is a next year.
Thanks for watching. If you want more fun content, be sure to subscribe and ring the bell to be notified about our latest videos. Thanks to all of our co-executive producers on Patreon and Tier 2 Plus subscribers on Twitch, keeping fun loud, live, and independent.